Hey guys, I'm Alex with SimSystem. In today's video, I'm going to show you how to properly nest full arch all-on-X cases using MillBox. Okay, so in today's video, I'm going to show you how to nest two different kinds of full arch cases, all-on-X cases. The first one is going to be a hybrid anatomic bridge that's going to have pass-through screw channels, so it won't have a screw seat on the internal of the drilling axis channel, and it won't have any interfaces because it's going to be cemented down to a tie base or tie base MUAs. But the key thing is that it's not going to have a screw seat, it's going to have a pass-through screw channel. That's going to be an anatomic abutment bridge. The second case is going to have interfaces. We'll import that as an implant abutment bridge that is going to have the screw seat on the zirconia that we need to mill, and it's going to have the interface for our screw system. So with that, let's get into it. All right, so we've got MillBox open, and the first case, like I said, we're going to do is going to be a case with no screw seats that's not going to have an interface. The first thing we're going to do when we open MillBox is go to the top right-hand corner and click on New Job. It's going to pull up our machine list, our tool packages. We're going to select our machine. In this case, I'm just using SimSystem. We're going to go through our materials, and I'm going to choose zirconia. That's going to be what we use. And then I'm going to use the C-clamp fixture. That way we can put the facial on the open part here, and we can paint it and get great detail that way. I'm going to go ahead and click the blue check once I'm happy, and it will go ahead and pull up my STL file window so I can go ahead and select my files. So I've got a file here that we'll use. I'll show it to you. Like I said, this one has no screw seat, so when we look from the top of the part, we're not going to see an additional circle in here because that would be the screw seat. So in the second case, I'll show you, you'll be able to see the screw seat right here. You'll see a second circle on the interior. But like I said, this case is just got passed through. It's going to be cemented down here in the cavity. All right, so make sure that you select the right part type here. Because if you were to click anatomic abutment bridge for this case, MillBox is going to look in the metadata or just at the curves and surfaces for interfaces and apply the wrong curves and surfaces potentially. So make sure that for this case, because it has no screw seat, we're going to import this as a hybrid bridge. So I'm going to click the check to proceed forward with the nesting. And here what MillBox is doing is MillBox is loaded with a bunch of automations and features to do part-based recognition, which means that MillBox is analyzing the STL file. If we have metadata, it'll just read the metadata concerning the margin line and all the different preferences that you set. But if you don't have metadata, MillBox can still read the file and look at the STL for the surfaces and just look at the geometry itself. And then MillBox will go ahead and assign the necessary curves and surfaces to your part. It is important that you select the right part type though, so that MillBox is detecting the exact curves and surfaces that you need. So this is going ahead and it's finished importing here. And now I need to go ahead and select my material. So you'll notice at the top, it has a minimum thickness required of 22.03. So I'm gonna go ahead and I'm gonna select a 25mm disc to make sure that it fits properly. I'm gonna do a new disc for this one because it's a pretty big case. And we'll just give it a stock name. We'll just call it test, lot code 123. We'll hit the blue check. And we'll go ahead and MillBox has auto nested this for us. Now, first thing I'm going to do, I'm going to bring it up right away. I'll rotate my part so that it lines up. Here, let me move this. We're going to bring it all the way to the open edge of our C-clamp, and we'll come back to that. Now, MillBox is turning the part yellow, and that's because it's getting dangerously close to the edge of our material. If I were to go outside the disc, you'll see it becomes red. So as long as it's yellow, we're okay, and we can optimize the amount of material that we will have left afterwards by moving it closely. So first thing I'm going to do, what I always do when I get a case in, we're going to go ahead and just check the curves and surfaces. So there are three things that we're looking for on this case. That's going to be the margin line, the reg caps, and the drilling access channel. Pretty easy. So we'll go ahead and check our margin lines first. Just make sure that they're present and detected properly. They should be here at the top of where the abutment is going to be seated. And I see that we have, this is acceptable. Yeah, they look good. And so then the second thing I'm going to check, I'll just toggle my translucency by clicking 9. And then that way I can see the drilling access channel curve, which is this green line here. What we want to check is just to make sure that the green line goes all the way from the top. And here, let me turn my fixture off with Control E. We don't need to see that, to the bottom. We need to make sure the green line goes all the way from the bottom of the cylinder that we have here all the way through to the top. So this one looks good. We'll check our others. This looks fine. It's good. It's good. Okay, so now we know that our margin line and our drilling access channels look good. I'm gonna go ahead and press 0 to get the translucency back to what it was. We can see our reg cap. So for this kind of case, we don't want our reg cap to be at the top here. We do have gray caps, which are the same type of a thing as a reg cap. Just during your initial operation, if you do Control G, you can see your gray caps. What these gray caps do is the gray cap will prevent the tool from dropping down inside of the cavity here. It'll just continue along the surface until we're ready to go and mill out those cavities, in which case we'll remove those gray caps. You'll still have the reg caps, and it'll mill out the internal of this area, but not go down into the screw access channel. So it's important that we have 2 reg caps on each of our drilling access channels, one at the top and one at the bottom. And so if I toggle my translucency by pressing 9, I can see through my part, and I just want to make sure that my reg cap is as close as possible to right here. This is acceptable, it's not too far down. We can take the auto detection here, and then we need to make sure we have one down at the bottom here. So we are good on the first one. Let's check our other ones. Reg cap, yes, looks good. And here, looks good. Yes, 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 yes. Okay, so our curves and surfaces are looking good. I'm gonna press 0 so I can just see the part again, and I'm just gonna hit home so it repositions everything. I'm also gonna turn back on my fixture with Control E, because we might wanna see it for this part as we're adjusting the 90-degree milling operation. So I have my part nested properly. Now I'm gonna go ahead and I'm gonna open up our offset and paint on our 90-degree milling operation, because for this case, we're gonna do 90-degree milling on the facial surface and just get all that detail that we're looking for. So the first thing I'm gonna do is go ahead and open up the offset here. So I'm gonna click my part, click on this little tool icon, and click on the open offset button. Automatically, MillBox is going to open up the offset for me and give a suggestion. We can make small adjustments, but let's see how it does. Okay, looks good. We can move the nodes if we want to in to get a little more space, but you can see maybe there's an error if we go too far in. We'll keep it there, that's fine. Okay, we'll go ahead and look at our facial. I can accept this. Yes, I want the parts to be milled on the open side. We might get an error here in a second after I'm done painting, but I'll show you how to navigate that. So now we have the paint options for our 90-degree operation. We'll make sure that our operation type is the 90-degree toolpath. I'm gonna check the fill selection option. That way I can just draw a circle around where I want to go. So I'll do it like so. So we'll go ahead and start painting the surface. And I'm just gonna make a big loop. And we just need to go across now. And when we connect it, MillBox will fill in everything we just painted, everything inside, and we can still make some more adjustments after that. Okay, so now MillBox has painted in my selection. Let's just go ahead and look at it, make sure that we're happy. I'm gonna fill in some of these areas really quick. So let's go ahead and we can keep the fill selection on. I'll just select a section here. Here, let's go around it. Here, let's bring this down as well. We'll let that process. I can get right here too. Here, let's just bring it over while we're at it. Okay, that's all painted in. Let's get this side. I'll start here. Just get all of that remaining that we missed. Okay, we've got our facial painted. Got our 90-degree milling operation set up. It looks good. So I'm gonna go ahead and hit exit, and that will save this selection. Everything's looking good. I'm gonna go ahead now and we'll finish this case by just adding the sintering stabilizer, checking our support pins, and then we can go ahead and calculate. So let's add our sintering stabilizer. So to do that, we're gonna go to Tools, Sintering Stabilizer. Now we have a few different options. For this one, I'm just gonna use our standard sintering stabilizer, the first option, but just know that we have several different options in here. Some can allow you to nest inside the physical space of the sintering stabilizer, like if you've got a crown or two that'll fit in there, you can save some material that way. Let's go ahead and just click on our part and it'll apply the sintering stabilizer directly to it. And you can make adjustments. You can see MillBox automatically moves some of the pins a little bit and placed everything. You can adjust the height here if you'd like to, just remove less material, or if you need to get greater access into just back here, then you can lower the stabilizer and you can make it wider. But honestly, this looks good. I'm happy. Might be able to get another case in here as well. And so I'm gonna just accept that. And now the last thing I need to do is just go ahead and add any additional support pins that I wanna add. So I need to add some on the back of my sintering stabilizer here. I'll just add here, let's zoom in. We'll just add 4. 1, 2, 3, 4. Okay, and so then we can go ahead. I think we might need a couple more just in here. Maybe we should move the placement of our support pins slightly. Here, let's zoom in. Okay, that looks fine. We'll just add a couple more support pins here. Okay, we'll just move this last one back here. All right, and with that, we're all set. So we can go ahead and when we're ready, we've got everything ready for this case. We can go ahead and click Save Toolpath. MillBox is gonna bring up the available milling options for this job. So we're gonna go ahead and because we painted in those surfaces, we're gonna click on the Special Machining 90-degree mill painted facial surfaces. That's gonna be with the 1mm ball tool. I can show you an image of that going across the facial. And then we'll go ahead and we'll add this 0.6mm ball tool as well for the rest milling. I can show you that. Just get in some of those details. We also have, you don't have to paint your surfaces if you don't want to. We just have a default option if you want to just do 90-degree milling on all facial surfaces. You can just click on that option and we'll create a toolpath for you for the 90-degree operation without having to paint. But because we painted, we're gonna go ahead and select these two options and proceed forward. Once you get to a certain point in the calculation, MillBox will display a tools table for you. This is just gonna show you what tools you need to have in your tool slots, your numbered tool slots, to make sure that everything in your machine with your tools matches what the CAM software is expecting. So make sure that your tools are the same in your machine as how they're listed on the tools table here in your CAM software. All right, so we'll let this case finish calculating and I'll go ahead and open up a second instance of MillBox while that calculates in the background. All right, so I've got my second instance of MillBox opened up here. So our second case then is gonna be another full arch case, but this time we're gonna have screw seats and we're gonna have interfaces. So for this case, let's go ahead and get started. We'll go to the top right-hand corner, we'll click on New Job. Select our machine, our tool package is here. Select our material, which is zirconium. And again, we're gonna choose the C-clamp fixture so that we can open it up on the facial and do 90-degree milling if we want to. Then I'm gonna go ahead and we're gonna go into our STL folder and I'm gonna go find in our implant bridge a case that we're gonna use. Let's go ahead and take a look at this case and I'll show you what I mean about the differences. Like I showed you in the last case, we had pass-through screw channels. We did not have the presence of a screw seat. This time, if we look from the facial, you're gonna see two circles right there. We have an internal and an external. And this part right in here is gonna be our screw seat. So the screw's actually gonna go down on top of this little screw seat right here. And we'll also need to make sure that our interfaces are detected properly on this case. So let's go ahead and we will import this case not as a hybrid bridge, that would be a mistake, but as an anatomic abutment bridge. Now MillBox is importing the part here. It's gonna auto nest for us, look for different curves and surfaces. And so we'll let this import here. All right, so we can go ahead and quick check on our curves and surfaces. I can go ahead and press 9. We can go ahead and check our reg caps, our drilling axis, and just make sure that the interfaces were detected properly. So I can see that the interfaces are present. Let's turn our reg caps off so we can see them. Everything looks good there. If I have a special screw seat like a Rosen, Powerball, seg screws, something different, we recommend that you use our replace library. And there's a video on our platform that can show you exactly how to walk through the replace steps so that you can make sure you're using all the most advantageous strategies for that. Otherwise, we're just looking to make sure that the interfaces have been properly detected, which it looks like they have been, that there's nothing kind of crazy going on with how they're placed. They're not placed like way up here, for example, or down inside the part. Everything looks good. So I can go ahead and check my other criteria, which let's just look at the drilling axes since they're available to us here. Again, just making sure that it goes all the way through to the top, yep, and down through the bottom. Good. We're just, again, making sure that it extends past. It's a long one, but yes, looks good. Let's angle this a little bit to see. Yep, looks good. And here we can zoom out and look at this one. Yeah, looks good. Okay, let's just check our reg caps. I noticed something with the reg caps, and maybe you did too. There's a lot of them. But don't be afraid if you see something like this, because you want to make sure that you have the top and the bottom reg cap. But if you have additional reg caps in the middle here, that's not going to affect your milling outcome whatsoever, because all we're doing is, it's already been blocked here at the top and the bottom. So anything additional inside is irrelevant, and you don't need to pay attention to it. So if you're getting something like this where you have a reg cap down inside the channel here, you can delete that. But in this case, I'm not going to delete any because, again, they're not going to make an impact on the milling result as long as we have the reg cap at the top, which we do. It's a little faded out due to the translucency, but here it is right at the top and down at the bottom of the channel. Here, let's just look at it without the transparency, and you can see our reg caps are all placed nicely there. Yep, yep. And we'll just make sure that they're present at the top. Yes, yes, yes. And so that's going to block any operations from going down inside of those cavities or the drilling access channel. Keep the operations all separate there. So this looks good. Again, we haven't even added our material yet, so let me go ahead and just add the material here. We did it a little out of order compared to the last one. This is a 21.03 minimum thickness required, so let's go ahead and grab a 22 millimeter disc. That should fit it fine. We'll name this just test 2 and 1, 2, 3, 4. MillBox is going to go ahead and auto nest this in here, but we know we're going to move this to the open face of the C-clamp, so let's go ahead and do that right away. We'll click on our part. We'll turn it around. So we'll go ahead and place it in our disc right there. I might want to turn it a little bit more. All right, and so we've got it nested here. Let's go ahead and we will open up our offset right away, so we can go ahead and click the tools, the open offset button. MillBox will automatically create the offset for us. Good. That looks fine. We'll go ahead and accept the selection. Yes, we want the parts to be milled on the open side. Great. So now we can go ahead and we can begin painting our facial again. So we'll go ahead and select our operation type, select the 90-degree tool path. We'll check the fill selection, and I'll begin to paint the facial. All right, we'll let MillBox fill that in. And there's that error that I said we might get last time. I'll show you how to fix that in just a second. We didn't get it last time. And let's go ahead and just finish filling this in, make sure everything looks good, get the rest of this tooth here as best we can. That'll paint that in. All right, that's good. And we'll go over here and get the rest of this quick. And one more little area here I see. Let's get that. All right, and this looks good. So let's go ahead and we can exit, and that will save our selection. Now, like I said, we've got this error here. There's a problem with the part border. Check to ensure no overlapping. So what we need to do here is just redo our offset. So let's click on our part. We'll go to the tools. We'll go back to our offset. We'll click that. It should remove our offset. You can see that material just came back in. Let's click it again, and that'll redo our offset. MillBox should fix that error that we just had here once it goes through the process. Perfect. We'll click to accept it. Everything's looking great. We just need to add a sintering stabilizer. So let's go ahead and go to our tools, sintering stabilizer. Again, we're just going to use the first option for this. Click on our part. It'll apply the sintering stabilizer automatically for us and add some connected your support pins and everything. We still need to add a couple support pins to the back. Speaking of support pins, let's go ahead and get rid of these yellow ones. This all looks good on the placement here. Let's go ahead and just add support pins to the back of our part here. I'll toggle translucency and we'll just go ahead and add some support pins. And this is looking good. Everything looks ready to go. We've got all of our curves and surfaces checked. We've got our sintering stabilizer on. 90-degree operation has been painted. We're ready to go. Let's go ahead and select Save Toolpath to begin our calculation. Now, first thing is going to be that MillBox again pulls up the milling options. So let's go ahead and select those special 90-degree mill painted facial surfaces. We'll go ahead and click the blue check to select our options, and MillBox will begin the calculation. Again, we just have our tools table here. So again, make sure that the tools are in the proper tool slots with your machine, and you'll be good to go. We'll just finish calculating quick and just come back and check and make sure everything looks great. All right, so now while our other case is calculating, I've gone back to the first case, the hybrid anatomic bridge, and we can see that the toolpath is calculated. It tells us where that file is located, and we can just go ahead and click OK. If we want to go run the simulation, we can click on the simulation. We can go ahead and run the simulation if we want to. We can either just show the residual material, or we can go run a full kinematic simulation if we want to. And that's it. Thank you guys for watching. If you need help processing these all-NX full arch case types, or you have other questions, feel free to check out the other videos here on the playlist. We have a video that's specifically for replacing Rosen screw, Powerball, seg screw, special interface geometries. We've also got an online help portal with plenty of videos and help resources for everything MillBox. So help.simsystem.com is a great place for you to go for all kinds of tutorials related to MillBox. Thank you guys for watching. Ciao.